widely used textbook in art history. Our camera, in this case, is above the object. Parallel lines lead to vanishing points, and the vanishing points are on a horizon line that are at the height of our camera. I'm going to show you a photograph that I made where the camera's below. It's of a chandelier, so we should have vanishing lines down here. It doesn't look like we were taught. I can guarantee you that this is an optics-based image. I took that photograph myself with my own digital camera. Yet it doesn't agree with what we were taught it should do. And the reason is that slight deviations of where those arms are, and those arms are presumably in good enough position to convince you to pay several $100s to buy that chandelier, that slight deviations that are not noticed by the eye lead to just this total incoherence. Science has to be reproducible. That's a different chandelier in a different Home Depot, and it both agree here. So deviations from what we've been taught of a geometrical perspective are going to be one of our clues of whether optics were used. Here's David Hockney visiting my lab. If you didn't know how tall David Hockney was, and you probably don't, you could look up in an almanac to make an estimate. What's the average height of a European male? And that's 1.75 meters. There's Ren Weschler also visiting the same day. That tells us the horizontal distance across the scene at the depth into the scene at which David Hockney is standing. Well, everyone knows a molecular beam epitaxy console is 2 meters long, so we don't have to look that up. And that tells us that a 22 millimeter focal length lens was used to take this photograph. My technician used a 24 millimeter focal length lens. Now, that's not magic. That's geometrical optics. That within the uncertainty of just our estimates, we can, if we can find, if Jan van Eyck painted a molecular beam epitaxy machine, we're in great shape. We can determine the focal length of the lens that he used, and we're going to make use of this. Here's Arnold Schwarzenegger. Even if you get nothing else out of this lecture, I'm going to affect the way you look at movies in the future. Arnold looks back into the scene. What changed? Well, clearly, the cameraman focused further in, but that's not all that changed. If I bring Arnold's head back, there are two equations of geometrical optics. There's the trailer. We can know how big his image was originally projected because it was shot in a particular format we can look up. I know how tall on the negative that film was. We can estimate how tall Arnold's head really is in real life. The magnification is 0.06. I remind you, go look at any Renaissance portrait out here. The magnifications of the Renaissance portraits aren't 0.06, they're 0.6. They're more like half life size or close to life size. So they're 10 times larger magnification. The effect is that I'm going to show you, which is real here, is even magnified more in the paintings. The length of the trailer from those kind of fuzzy out of focus images, we have Arnold look halfway back. It seems like the trailer shrunk. He looks all the way back, it shrinks some more. Well, it doesn't shrink. It was an 8% change in a movie that all of you saw, and you never noticed that change. You'll never not be able to notice these changes in the future. That one of the consequences of refocusing further into a scene reduces the magnification of the image. We're going to make use of that. Again, for you guys in New York, that's a mountain. So we can...
If I let you know where I'm going.
We come in on Tom here. The mountains were a little bit out of focus before. Now they're totally out of focus. Again, we do the same kind of estimate. I'm going to go through this very quickly. Different format, different size. My estimate gives me about the same size for this. But when we come in, we've increased the magnification by a factor of 3, but we've decreased the depth of field of the scene by miles. So another thing, increasing the magnification decreases the depth of field. And the effect is much larger when the magnification gets even larger. And we have equations that we're going to throw at this and calculate this quantitatively. Something I want to remind you of, that we're all too familiar with photographs. It's distorted our way of understanding. I'm going to have to kind of remind you of things that you take for granted that are, in fact, weren't taken for granted before the first projected image. Human vision, we take in pretty close to 180 degrees, not with high resolution. Like right now, I'm kind of looking down the hallway, but I can see the exit sign, I can see that exit sign out of focus. So I'm seeing a huge angle. There is no camera lens, single camera lens, that'll take in that kind of angle. That photograph is taken with the widest focal length lens that is really available for a single lens reflex camera. Parallel lines remain parallel. But when I look this direction and I look that direction, I'm looking in different places. The magnifications change of the scene. And this is how the eye constructs a scene. Before images were projected, here's a painting before images are projected. Looks like that scene. I'm just offering this as something for you to pay attention to when you're looking at the paintings in the mat. So here's how we're proposing that optics was used. Here's somebody dressed up to look like Cardinal Albergati in a Van Eyck painting. There's David Hockney. The door is open so we can see inside. His image is projected and reflected upside down by that concave shaving mirror in living color. It's a movie. The artist then takes the few features he needs to know to continue painting the portrait. And a good artist may only need to capture the positions of the eyes, positions of the nostrils. Doesn't have to trace the whole image. But it's an optics-based image at this point, takes it down, and continues working from life. Fills in the rest. But the optics is already built into it at this point. And at this point, if you decide, well, I want to make this into a painting, well, you add the color. So I'm going to show you a 30-second clip of David doing this. Watch, the guy will blink. It's a movie in color. And David's actually tracing more just for the benefit of the camera than he needs to, far more than he needs to do these optics-based portraits. He's painted 4 portraits of me. I've watched him do this. He doesn't need that much information. Then takes it down, works from life. So at this point, this is an optics-based image in which there are non-optics components built in. The guy was sitting outside. Well, he can put him outside. He could have been painted in Iowa, but that doesn't mean that the artist doesn't have the artistic license to create a totally, out of his own imagination, scene and put him in the sea. Optics-based, non-optics-based. Or he can put him inside. Or he can put him with his friends. These are collages that are evidence. All the evidence I'm going to show you is some features of some paintings were created with the aid of optics. Now, that's not a weak statement. That's a hugely strong statement about the use of optics, but also that's a limitation on it, because you're going to have to know what features to look for to know where the artist used optics. It also does not take away from the creativity. In the Arnold Feeney marriage, if you remember, there's a husband and a wife. The woman's in green. The husband's on this side. The artist created that composition himself. He may have decided the woman wore a purple dress today. I don't like purple. I'm going to put it in green. He has all sorts of choices that are made. Optics helps him with some features. But it doesn't create all this. So where would optics help with this painting? Well, there's a little dog in this painting. If we magnify the dog, we can identify its breed. It's a Bichon. In fact, I have a colleague who raises Bichons, and he assures me that if you have a camera and you have it set any slower than a 500th of a second, the dog's a blur. So we learn one of two things of this. Either Van Eyck convinced the Arnolfinis to let him kill their dog and stuff it so he could project the image, or Van Eyck had the skills to create a Bichon with his pure artistic skills, if we say alone, his unaided by optics skills alone. So he had the skills. This tells me that Van Eyck has the skills, if you would say, to not have to use optics, if you want to put it that way. But, as I will show you, whether or not he had to use optics, he did use optics. Those are logically separate propositions.